Hi, my name is Jean-Claude Clark, and in this video we will go through part 2 of the step-by-step walkthrough of the magnetically coupled resonant wireless power transmission printed spiral coil design process used in the design of our coils for cell phones. As stated in the beginning of the previous video, that name and its acronym are too long to be used in this video, so we will shorten it to the MCR coil design process moving forward. Alright, let's get back to the video. In part 1 of the walkthrough, we completed the momentum portion of the design process and imported the design into EMPro. In this second half of the walkthrough, we start with the modification and rearrangement of the imported design assembly and end at the simulation of the final EMPro design assembly and export the design results into ADS. So let's get right to it. Beginning where we left off, the first thing we do with the imported design is to remove all unnecessary parts. We begin by removing the simulation box, then the ground plane, and finally the ports. Next, we open up the scripting editor to copy an existing Python script that we created, and we run it to generate additional parameters that will be used to modify the assembly and set up a parametric sweep simulation. With the parameters added, we modify the location of the imported board assembly. A copy of the board assembly is then created and its orientation and location are changed. We move on to the boundary conditions, which are then set to absorbing for the X, Y, and Z axes. The FEM padding values are set to the maximum coil length in the X-axis, the coil width in the Y-axis, and the separation between the two coil assemblies in the Z-axis. DC feed ports are then added to the original assembly and the copied assembly at the inner coil of both assemblies. We now move on to the FEM Simulation Setup, which is adjusted as follows. In the Field Storage tab, we save all the frequencies. Moving to the Mesh Refinement properties, in the Advanced tab, we compute the initial mesh size. Using this value, which we automatically determined, we move on to the initial mesh. With fix for all conductors selected, we enter the initial mesh size value in the edge mesh length and the vertex mesh length fields. We also change the target mesh to a custom target mesh size with the value shown here. In the final part of the simulation setup, we create a parametric sweep on the separation distance between the MCR coils in the Z-axis, ranging from 0.5 to 3 inches in increments of 0.5 inches. With the design assembly and simulation setup complete, we run the simulation. From the results, we see that the resulting SRF is approximately 6.43 MHz. The maximum S21 and the peak S21 at the critical coupling distance are approximately -1.47 dB and -2.10 dB. Finally, we export the simulation results as an EM model so that they can be used within ADS with other simulations such as the maximum peak detection and auto-tuning system. And with that, we complete the step-by-step walkthrough of the MCR coil design process. Thank you for watching my video, and I hope you enjoy the rest of your day.